day, everyone! We have learned a lot about the different functional groups in our past lessons. Today, we will be bringing more knowledge on the table as we will be discussing several other types of functional groups. I am Crystal C. Simera, and together with my group mates Chloe Brian Macavinta, Xavier Robelo, Adriel Joy Sison, and Danica Uy, we will be discussing aldehydes, carboxylic acid, ketones, amides, esters, and acid anhydride.
Hello everyone, my name is Chloe and today we will be discussing and naming two of the most common functional groups found in nature, the aldehydes and the carboxylic acid. Aldehydes are commonly found in essential oils and distinctive for its favorable odor. Carboxylic acid is found in both plants and animals. In plants, it can be found in citrus fruits because it contains citric acid, which is a carboxylic acid. So starting with aldehydes, always remember that when it has a suffix al, and as a substituent, it is called an oxo. So first, let us try to name aldehydes. So again, start to determine the number of carbons in the parent chain. So this has 6 carbon chain, meaning it is an hexane. So this will be called as hexanal with al as the suffix. So next, we have here an alkene attached in this aldehyde. Again, determine the number of carbons in this parent chain, and since it has 8 carbon chain, this will be called as an octene, not octane. We have the alkene at carbon 3, so this will be called as 3-octenal or 3-octenal. So this is aldehyde that has substituents. So in naming that, look for the position of each substituent and always name it alphabetically. We have here the bromine and the methyl group. So B comes first, so it will be named as B-bromo-4-methyl, and since it is a 6 carbon chain, it is an hexane, so it is an hexanal. So it's called 5-bromo-4-methyl hexanal. Next, we have here a cyclic chain, and this is a cyclohexane, and because this is an aldehyde, it will be added with the word carbaldehyde at the end. So this will be called as cyclohexane carbaldehyde. With substituent, find the lowest position. So the methyl group is in carbon 3, so this will be called as 3-methyl cyclohexane carbaldehyde. We have here a benzene ring attached to an aldehyde, so this will be called as benzaldehyde. So next, let us try to draw the structure for aldehyde. We have here 4-bromo, 5-methoxy, 6-methyl heptanal. Heptane is a 7-carbon chain. So remember to put the aldehyde at the end of the chain always and start to look for the position of each substituent. So the ether or the methoxy group is in carbon 5, the bromyl group is in carbon 4, and the methyl group is in carbon 6. So that is how you'll name this 4-bromo, 5-methoxy, 6-methyl heptanal. So next, we have here the carboxylic acid. Always remember its suffix IOC and acid at the end, or ioic acid, and always remember that it has the highest priority. So we have here a carboxylic acid, so start counting at the end. So this is a butane. So as a carboxylic acid, this will be called as butanoic acid. Next, we have an alkene attached in this carboxylic acid. So again, determine the number of carbons attached to the parent chain. So this is an hexene. So the hexene or the alkene is attached at carbon 3. So this will be called as 3-hexene-noic acid. So we have here a cyclic chain. So this is a cyclopentane particularly, And as a carboxylic acid, it need to be added at the end of the name. So this will be called a cyclopentane carboxylic acid. So with a substituent, always find the lowest position. So the bromine group is in carbon 3, so this will be called as 3-bromo cyclopentane carboxylic acid. So we have here a benzene ring attached to the carboxylic acid, so this is called as benzoic acid. So next, let us try to draw the structure for carboxylic acid. We have here 5-chloro-4-ethyl hexane dioic acid. So notice that I have the word di, meaning it has 2 carboxylic acid attached. So first, draw the chain, which is a hexane, and put the carboxylic acid at both ends and determine the position of each substituents. So the ethyl group is in carbon 4, the chlorine is in carbon 5, and that is how you name this 5-chloro-4-ethyl hexane dioic acid. And this is how you name aldehydes and carboxylic acid.
Ketone. Ketone is composed of 3 carbon chain. To have a ketone, the carbonyl group is supposed to be at the middle of the 3 carbons. This right here is called propanone, and its common name acetone. You need to change the suffix into "one." The pronunciation is "one," not "one." So we have here our first example. Here's the molecular formula. And here's the condensed structure of our formula so we can name it easily. So we have 7 carbons, and we need to locate the placement of our carbonyl group. We need to choose the lowest carbon number. Our carbonyl group is located at carbon 3. So we have 3-heptanone. Second example, here's the molecular formula. This time I'm going to show you its linear structure. Always remember that our ketone is more prioritized than our bromo atom. We have 1, 2, 3, 4, 5, 6, 7, 8 carbons. Carbon 8 is the location of our bromo, and carbon 3 is the location of our ketone, so we have 8-bromo, 3-octanone. Third example, what if we have a cyclic chain? Here is our cyclic chain. Always remember that we need to start counting at the location of our ketone. So we have 3-methyl cyclohexanone. We don't really need to write the location of our ketone because it is already known that it is at the carbon 1. Fourth example, what if we have 2 ketones? We have our linear structure here, so we have 7 carbons. All we need to do is to identify the location of our 2 ketones. Our ketone is located at carbon 2 and carbon 6. So we have 2,6-heptadione. We use the word di because we have 2 ketones in one structure. Here is our last example. We are going to draw this IUPAC name 8-bromo 6-methyl 2-decanone. Dec means 10 carbons, so we're going to draw 10 carbon chain. We need to look for the location of our bromo, methyl, and our ketone. We have our ketone right here, our methyl, and our bromo. I hope you learned something from here. Thank you.
In this lesson, we are going to name amides. Let's start with a very simple example, a 2-carbon amide. So 2 carbons is associated with the name ethane, but when dealing amides, you need to drop the E and add the word amide. So this is called ethanamide, while the common name for this is acetamide. Let's work on some other examples. What is the IUPAC name for this particular amide? We have a total of 3 carbons, which is associated with the word propane, and gonna drop off the word E and add amide. So this is called propanamide. How would you name this kind of amide? By the way, this is a primary amide because the nitrogen atom is only attached to 1 carbon. Now, we have a total of 5 carbons in the parent chain. So instead of saying pentane, we're gonna have pentanamide. Drop off the E and add the word amide. And we have a methyl group on carbon 2. Therefore, this is gonna be called a 2-methyl pentanamide.
Good day, everyone. My name is Crystal, and today I will be talking about esters. So esters are a functional group with 2 oxygen bonds, as you can see from this structure. there is a double bond and there is a single bond attached to the same carbon. Many esters are responsible for the fragrance and flavor of flowers and fruits. Like for example, isopentyl acetate is present in bananas. So now, I will be teaching you how to name esters. So going back to the structure, what you want to do first is that you divide the oxygen bonds. Next, we have to count how many carbons present in each side. So we have 1 and 2, so that is F. And the suffix for esters is oate, so this is ethanuate. For the left side, we have 1, 2, 3, so that will be propyl. So the name of this structure is propyl ethanuate. Let's try another one with substituent. Okay, same process, divide, and then count how many carbons. Again, this is 1, 2, ethanuate, and then here, you identify the longest chain. So 1, 2, 3, 4. So this is a butyl. But there is an attached methyl. So you have to identify in which carbon it is attached. So it is attached in the third carbon. So this is called 3-methyl-butyl ethanuate. Let's try one that is attached to the oxygen bonds. So again, we have to divide and then count how many carbons. So this is 1, 2, 3. So this is propanuate. Propanuate. And the methyl is attached to the second carbon. So this is 2-methyl propanuate. And in the left side, we have an ethyl. So this is ethyl 2-methyl propanuate. Let's try creating the structure given its name. So 2-methyl propyl, so that's 3. 1, 2, 3. 1, 2, 3. And then meth. So that means in the oxygen bond side, there is only one carbon. O. H. So we have one carbon here. And the methyl is attached to the second carbon. So this is the first carbon, the second carbon. So we have this one. So how about ones with benzene rings? So this one has 1, 2, 3, 4, 5, 6 carbons. So this is a phenyl. So this is phenyl. And then for this one, there are 7 carbons. So this is benzene. Benzoate. So that's it. Phenyl benzoate.
So for first example, we have this particular acid anhydride. This acid anhydride is symmetrical and it has 2 carbons. This structure is called ethane, but when dealing with acid anhydride, you take off the E and change it to OIC. So it is called ethanoic anhydride. The common name for this molecule is acetic anhydride. Next example is another symmetrical molecule. And this time it has 3 carbons on each side. It is associated with propane, so we take out E and change it again to OIC, and that makes it propanoic anhydride. Last example is an asymmetrical molecule. On the left side, it's only 2 carbons and it's associated with the word ethanoic. And on the right side, it's a total of 3 carbons which will be associated with the word propanonic. And since it's already in alphabetical order, we can just say it's ethanoic.